The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Joan Najita, a staff astronomer at the National Optical and Infrared Astronomy Research Laboratory, or NORLAB, which operates the Kitt Peak Observatory, among others. Welcome, Joan.
Great to be here, Tim.
Joan, we've been getting more and more results from something called DESI, or the Dark Energy Spectroscopic Instrument, that have important implications for the history and future of the universe as a whole. What is dark energy?
While we don't know what it is, we know that it is there because of the impact that we can see that it has on the expansion history of the universe.
How was it discovered?
Well, it was discovered completely by accident, completely unanticipated when people about 25 years ago were trying to, connect some of the dots and thought they would try to measure how much the universe is decelerating as it started to feel the impact of matter to slow down the expansion of the universe. So they started measuring it using what are called supernovae. And to their surprise, they found that the universe was not decelerating, but it was accelerating in its expansion.
So dark energy is just the term we use for whatever it is that's causing that expansion, right?
Exactly. We didn't know what it was, so we had to give it a name, and people coined the term dark energy.
What is DESI, and how does it fit into this picture?
So, as you mentioned, DESI is the Dark Energy Spectroscopic Instrument. It's on a mission to try to help us understand the nature of dark energy by constructing the biggest three-dimensional cartographic, map of the universe ever made.
How long will it take you to map the entire sky? That sounds like a daunting task.
Well, it's not the entire sky, but it's a large fraction of it. Our own Milky Way kind of gets in the way of looking beyond it for a large fraction of the sky. But apart from that, our goal is to map a significant fraction of that. And over a time period, that's about 5 years of observations. And it's what we're trying to do, it's a three-dimensional map. So we're looking at the sky in 2 dimensions plus the depth or time domain, which is through the spectroscopy.
What are the results coming out of DESI so far?
We were pleased to show that, I guess, cosmology is not exactly what we thought. Although people had interpreted the idea of dark energy as being a constant in time, that dark energy would always be present throughout the universe's history at a constant strength, the recent results seem to show that dark energy is actually weakening over time. It's evolving, it's dynamic, becoming less pushy. And that has some interesting consequences for us as humans, or our view of the history of the universe, but also for cosmology and for astronomy.
What are some of those implications?
Well, as humans, if you think about what does it mean for dark energy to be a constant, it means the universe is going to continue to accelerate in its expansion forever. And that would mean that eventually other galaxies would be much further away, and that our view of the sky would be much darker, lonelier, and cold. And some people might view that as kind of not a very optimistic outcome. But, if that's really not the case and dark energy is changing, other more optimistic futures are back on the table. For cosmology, I guess it's a big reset. We thought there was that dark energy, even though we didn't know what it was a constant. And maybe that was reassuring. It's a simple explanation or simple characterization of what we're seeing. But now that we're sort of liberated from that idea, perhaps, I think it opens up a wide range of other ideas. And so I think cosmologists are pretty excited about the open frontier.
Our guest today has been Joan Najita, one of the key people in the groundbreaking DESI project at Kitt Peak, studying the overall history of the universe. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.